Imagine a city, bustling, full of life. Skyscrapers touch the clouds. Roads hum with traffic. Homes filled with families. Now imagine it all gone, reduced to rubble, in mere minutes. This isn't a scene from a disaster movie. This is the reality of a magnitude 9.0 earthquake. It's an event so powerful, so catastrophic, that it can erase a modern city from the map. How does such an unimaginable force manifest? What happens when the very ground beneath our feet turns into a liquid wave? Today, we'll explore the science, the raw power, and the devastating aftermath of a magnitude 9.0 earthquake. First, let's understand the scale. Earthquakes are measured using the Richter scale, or more accurately, the moment magnitude scale, MMS, for larger events. It's a logarithmic scale. This means each whole number increase represents a tenfold increase in the measured amplitude of seismic waves. But more importantly, it represents about 32 times more energy released. So a magnitude 9.0 earthquake isn't just a little bigger than an 8.0. It's astronomically more powerful. To give you perspective, a magnitude 5.0 earthquake is strong enough to cause moderate damage to poorly constructed buildings. A magnitude 7.0 can cause widespread severe damage. A magnitude 8.0 is a great earthquake, capable of devastating large areas. But a magnitude 9.0, that's in a league of its own. It's the kind of event that fundamentally alters landscapes. It moves entire plates of the Earth's crust. These colossal quakes typically occur in specific geologic settings. They happen along subduction zones. This is where one tectonic plate is forced beneath another. Think of the ring of fire that circles the Pacific Ocean. This region is dotted with subduction zones. The Cascadia subduction zone off the coast of North America is one such area. The Japan Trench is another. These are zones of immense pressure that builds for centuries until it's suddenly released. The energy released by a magnitude 9.0 earthquake is equivalent to tens of thousands of atomic bombs. It's not just a tremor, it's a sustained, violent shaking that can last for several minutes, sometimes for over 5 minutes. That might not sound like a long time, but when the ground is heaving and twisting, every second feels like an eternity. What happened? The mechanics of destruction. When a magnitude 9.0 earthquake strikes, the immediate effects are terrifying. The first thing people experience is intense ground shaking. This isn't just a gentle sway. It's a violent, multi-directional motion. Buildings are subjected to immense stress. They're pulled and pushed from side to side, up and down. This can quickly exceed their design limits. Imagine a tall skyscraper. It's designed to flex, but a 9.0 earthquake can create forces it can't withstand. Structural columns buckle, beams snap, floors pancake down on top of each other. Older buildings, especially those made of unreinforced masonry, simply disintegrate. They crumble into piles of bricks and dust. Even modern, earthquake-resistant structures will suffer severe damage. Some may collapse entirely. But ground shaking is just the beginning. A critical phenomenon called liquefaction often occurs. This happens in areas with loose, saturated soil. The intense shaking causes the soil particles to lose contact with each other. The ground temporarily loses its strength. It behaves like a liquid. Buildings can sink into the liquefied soil, or they can tilt and topple over. Entire neighborhoods can be swallowed by the earth. Roads crack and buckle. Underground pipes burst. Utility lines are severed. Landslides are another major threat. Steep slopes, especially those already unstable, will give way. Massive amounts of earth and rock can come crashing down. They bury homes, roads, and anything else in their path. This is particularly devastating in mountainous or coastal regions. Then there's the tsunami. Almost all magnitude 9.0 earthquakes occur under the ocean. The sudden vertical displacement of the seafloor by several meters acts like a giant paddle. It displaces an enormous volume of water. This creates a series of powerful ocean waves. These waves travel across entire oceans at speeds comparable to a jet plane. In the deep ocean, they are barely noticeable, but as they approach coastlines, they slow down and grow in height. A tsunami from a magnitude 9.0 earthquake can be catastrophic. Waves can reach tens of meters high. They crash ashore with incredible force. They sweep away buildings, vehicles, and people. The initial waves are often followed by even larger ones. The destruction from a tsunami can far exceed the damage from the initial ground shaking. Fire is also a significant secondary hazard. Broken gas lines and electrical wires ignite. This often happens amidst a city already in ruins. With water mains broken, firefighters struggle to contain the blazes. Post-earthquake fires can rage uncontrolled for days. They add another layer of devastation. They can consume what the earthquake and the tsunami left standing. The sheer scale of destruction is almost incomprehensible. Entire urban centers are rendered inhabitable. Infrastructure collapses. Transportation networks are destroyed. Hospitals are overwhelmed or damaged. Communication systems fail. It's a total breakdown of society's most basic functions. Why it matters. The aftermath and lessons learned. The immediate aftermath of a magnitude 9.0 earthquake is chaos. Rescue efforts are severely hampered. Roads are impassable. Communication is cut off. Many survivors are